Here is a walkthrough of the extra practice for Unit 2, graphing by a table of values. So we're going to use an extended table of values to calculate each y value. Just to clarify what needs to be done here, we're using this equation, and I'm going to forego making the table of values the first time, but I'm just going to give you a certain x value. So if x is equal to 4, then y is equal to 2/3 times 4 minus 1 plus 4. So what do I do first? I subtract the 1 because that's in parentheses. So we have y equals 2/3 times 3 plus 4. And then after I do that, then I multiply by 2/3. 2/3 times 3 is 2, and finally add 4. So the end y value would be 6. So that means when x is 4, y is 6, and we can graph that as a point on the graph. A way to organize this so I can do multiple calculations all at once and get multiple points on this graph is to set up a table of values. So now I'm going to erase what I did, and I'm going to set up a table of values that will walk us through those operations. So I'm going to pick an x value, and then I'm going to subtract 1 from that x value, and then multiply that result times 2/3. And finally, I'm going to take that result and then add 4 to it, and this will be my y value since y equals that. So what I need to keep in mind is that I'm going to multiply some of these values by a fraction 2/3. And when multiplying by 2/3, it's easiest if we keep the numbers that we're multiplying by 2/3 multiples of 3. So I'm going to pick -6, -3, 0, 3, and 6. When I multiply them by 2/3, we get -4, -2, 0, 2, and 4. And then in the last column, we just add 4 to each of those values. That'll give us 0, 2, 4, 6, and 8. Now we have to do the task of working backwards from x minus 1 to x. So for instance, if x minus 1 is equal to -6, I can add 1 to both sides of the equation to get x equal to -5. So in order to move from the x minus 1 column to the x column, I need to add 1. Add 1 to -3, add 1 to 0, add 1 to 3, and add 1 to 6. When I'm done with my table of values, these are my x values and these are the corresponding y values, which I can now graph on the grid to the right. So we have the point -5, 0, -2, 2, 1, 4, 4, 6, and 7, 8, which is going to go off of the grid that we have to graph in. So that's going to be enough points. And now I've graphed all of the points explicitly that have integer coordinates. All right, let's do the same for this, which is a different kind of function. So this one won't necessarily be a line. In fact, it won't, because we see that the variable is squared here. So in order of operations, if I replace x with a value, my first task will be to add 3 to it, and then take that result and square it, and then finally to take the square of that result and subtract 5. So when considering an equation of this sort, I want to always make sure that I am squaring some negative numbers and some positive numbers. That will ensure that I see the main part of the graph where it's changing direction. So I'm going to include as my x plus 3 values -3, -2, 1, 0, 1, 2, and 3. We may not necessarily use all of those values, but it's probably best if we include them. Then the next column to the right is the square of that result. So that will be 9, 4, 1, 0, 1, 4, and 9. And then the last column, take all of those values and subtract 5. And that gives us our final y values. The last thing we need to do is find our x values. So to move from the x plus 3 column to the x column, we need to subtract 3. And finally, we can graph all of the ordered pairs, x comma y, in our table. And we have the point -6 comma 4, -5 comma -1, -4 comma -4, -2 comma -5. Sorry, that was -3 comma -5, -2 comma -4, -1 comma -1, and 0 comma 4. And that gives us this parabola shape, which is a curve, so make sure that you are not connecting it with straight lines. The next equation has absolute value in it, so it's going to be yet a different shape. So let's take and make our extended table of values. Whatever x value we replace the variable x with, the first thing we'll do is subtract 4 because that's inside the grouping, then take the absolute value of that, and then finally multiply that absolute value by 2. And that last column will represent our y's because y equals 2 times the absolute value of x minus 4. When working with absolute values, just like when working with a square, it's important that we have some negative and some positive inputs to the absolute value. So I'm going to use -3, -2, -1, 0, 1, 2, and 3, and I'm choosing x minus 4 because x minus 4 is what we're going to take the absolute value of. In the next column, take the absolute value of each of those values, and then in the next column, we need to multiply each of those by 2. 6, 4, 2, 0, 2, 4, 6. And then lastly, to move from the x minus 4 column to the x column, we add 4. And the first column represents our x values of each ordered pair, and the last column represents our y values for each ordered pair. So we have the point 1 comma 6, 2 comma 4, 3 comma 2, 4 comma 0, and lest you think this is a straight line, next point is 5 comma 2, next is 6 comma 4, and then finally 7 comma 6. So we can see that this absolute value function looks like a V shape, or that rather the graph of this absolute value function looks like a V shape. This does get connected with straight lines because you can see that each of these pieces, each side of the V, is in a straight line. However, the graph itself is not completely a straight line, it's a V shape. All right, let's take a look at number 4. Let's set up our table of values. So our columns are x, x plus 3, -1/2 times x plus 3, and then finally -1/2 times x plus 3 minus 1. And the numbers that we will multiply by -1/2 are the x plus 3 column. So those need to be multiples of 2. So let's plug in a few multiples of 2, -4, -2, 0, 2, 4, and see what happens. Times -1/2 is +2, 1, 0, -1, and -2. And then lastly, subtracting 1 for the last column gives us 1, 0, -1, -2, and -3. Those are our y values. Now let's work backwards from x plus 3 to get the x values. To get to x from x plus 3, we subtract 3. And then we have a bunch of x values and y values paired up so that we can graph them. -7, 1, -5, 0, -3, -1, -1, -2, and 1, -3. We'll notice that I don't have enough values here, but I can observe that I've graphed enough points to verify that this is for sure a straight line. I don't see any absolute values or squares, so no extra types of operations that would result in a different shape. So I'm just going to continue to use the same slope to graph some additional points and then connect the dots to form the continuous graph with arrows on the end, and that one's a straight line. All right, let's move on to number 5. For 5, we can set up a table of values, and if I look at the order of operations for replacing x with after we replace x with a number, my first operation would be to do the exponent, to do the squaring here, and then multiply that by -1/2, and then take that result and add 3, and that's going to give us our y value. So I have to consider a couple of things here. I'm going to square some numbers, so I need to choose some negatives and some positives. And then we're going to take that result and we are also going to multiply it by -1/2. So it has a denominator of 2, so I want my numbers that I input here to be numbers that are multiples of 2. So let's take -6, -4, -2, 0, 2, 4, 6. Square each. And then multiply each by -1/2. Oops. And I don't know where I got half of 16 was 6, but it's not, it's 8. So that number there should be 8. Let me fix that. And half of 36 is 18, so -1/2 of it is -18. And then lastly, add 3. And I notice I dropped a negative there. So adding 3 to -2 would give us 1. Adding 3 to -8 would give us -5, and adding 3 to -18 would give us -15. I'm not going to be able to graph that one or that one since the y values are too large, but I can certainly graph the rest of it. -4, -5, -2, +1, 0, 3, and be really careful where you graph it, and I will try to be too. And then we have 2, 1, and 4, -5. And we have a nice parabola shape that will always occur when we have a square in the equation. The next one is an absolute value, so we're kind of expecting a V shape here. So let's create our table of values. When we replace x with a number, the very first thing we are going to do is subtract 5, then take its absolute value, and then add 3 to that. And when I'm considering absolute values, I need to make sure that I'm taking the absolute value of some negatives and some positives. So since x minus 5 is what we're taking the absolute value of, I want to make sure that that sees some negatives and positives. Take the absolute value to get the next column, and then add 3 to each to get the next column. And lastly, to move from x minus 5 to x, add 5. And our first and last columns give us our x, comma, y. So first point is 2, 6. Next is 3, 5. 4, 4. 5, 3. 6, 4. 7, 5, and we can't continue really after that, but that's okay because we have seen the most interesting part of this graph, and that would be the V shape. So we know this is not a straight line since it's an absolute value graph. All right, let's try number 7. For this one, I'm starting with an x value, and then I add 2 because that's in the grouping, and then multiply that by negative 5/3, and finally take that result and add 1. The numbers we're multiplying by negative 5/3 are the x plus 2's, so those need to be multiples of 3. So I'm going to use negative 3, 0, 3, 6, and hopefully that's enough points, times negative 5/3 gives 5, 0, negative 5, and negative 10. Add 1 to each of those gives 6, 1, negative 4, and negative 9. Lastly, to move from the x plus 2 to the x column, subtract 2. And our first and last columns are the x, y pairs. So negative 5, positive 6 is 1 point. Negative 2, positive 1 is another. 1, negative 4 is another. And that last point, 4, negative 9, I will not be able to graph, but I believe that we can verify here that this is a straight line. I don't see any of those extra operations like absolute value or squaring. This is just strictly multiplication and addition on the variable, and so that's going to form a straight line, so it would be reasonable to assume that we can just continue the line and connect and put arrows on the end. For number 8, what we're going to do is create a table of values, and in my table of values I'm going to start with an x value and then add 4 since that's inside the grouping, and then take the absolute value and then multiply that by negative 1. So negative 1 times the absolute value of x plus 4. So that negative sign just means we're going to multiply that result times negative 1. And then lastly, negative 1 times the absolute value plus an extra 1. When we're taking an absolute value, we want to use some negatives and some positives. So I'll use negative 3, negative 2, negative 1, 0, 1, 2, and 3 for x plus 4 values, since the next column takes their absolute values. We always want to take the absolute value of some negatives and some positives. And then the next column we multiply each by negative 1. And then finally add 1. lastly, to get our first column for the x's, we're going to take the x plus 4's and subtract 4. So if x plus 4 equals -3, then subtract 4 from both sides. X is -7, -6, -5, -4, -3, -2, -1. There are our x, comma, y values. -7, comma, -2, -6, comma, -1, -5, comma, 0, -4, comma, 1, -3, comma, 0. There's where the graph is going to go back downward. And -2, comma, -1, and -1, comma, -2. I'm just going to continue that same pattern since we've already seen the turning point. I know that the rest of the graph just continues from there. And then I'm going to connect my nice V shape. This is piecewise 2 different lines that are connected at a V or a vertex. And in 9, we have another squaring function. For the squaring function, we're going to find our x, add 1, then square that result, and then take that result and multiply by 1/3. And lastly, take that result and subtract 6. So these are going to give us the different columns of the extended table of values. Since I'm multiplying each of these squares by 1/3, I should probably pick multiples of 3 to square, and I want to pick some numbers to square that are negative and some that are positive so that I see the turning point of this graph. So I'll pick -6, -3, 0, 3, and 6, and then square each, and multiply by 1/3, and finally subtract 6 from each. And then to move from the x plus 1's to the x's, subtract 1. And the first and last columns are our x, comma, y's. So we can graph each of those pairs. -7, comma, +6. -4, comma, -3. And -1, comma, -6. -2, comma, -3. And lastly, 5, comma, 6. And then we can connect, and we see that nice parabola shape. As long as we square some negatives and some positives, we'll see that nice turning point in the parabola. For the last of the graphing examples, note that we have a different exponent this time. That is a power of 3. So, in order to create this extended table of values, when we replace x with a number, the first thing we'll do is operationally subtract 1, and then cube that result. When we raise something to the 3rd power, that is called cubing. When we cube, it's important that we consider some negatives and some positives. I'm not going to put too many in here, and you'll see why. When we cube each of these values, that's multiplying it by itself and then by itself again. So -2 times -2 times -2 is -8. That is, exponentiation represents repeated multiplication. -1 times -1 times -1 is -1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. To go from the x minus 1's to the x's, I'm going to add 1. And now we have our x, comma, y pairs. So I'm going to graph those. -1, -8. Well, I don't have too many points to graph here, but I certainly could locate this one. It's just a little bit above our grid. Just for accuracy of the graph, I'd like to kind of eyeball where that is. Next, 0, and actually, you know what? I graphed that one wrong, so I'm going to go back and regraph it. -1, -8, it's below the graph. 0, -1, 1, 0, 2, 1, and 3, +8, which I'm going to locate up here. See, it's actually pretty important that I get those last couple of points in, even though they didn't fit on the grid, because it's going to tell me a little bit more about the shape of the graph. If I just graphed the 3 points in the middle, I would be tempted to think this was a straight line, but it's most definitely not. It's kind of a sort of a water slide shape. I don't know what to call that. All right. In 11 through 14, we're finding the value of k if the given point is on the graph of the equation. So, if a given point is on the graph of the equation, that means the x, y working together make the equation a true statement. In 11, the y value for the given point is -1, and the x value is -7. So if I replace the x with -7, now I have -7 times k minus 3. Now let's add 3 to both sides, and we get 2 is equal to -7k. And lastly, dividing by -7, a positive divided by a negative is a negative, so k is equal to -2/7. For number 12, the given point is 1, 8, so 8 replaces the y value, and 1 replaces the x value. So now I need to do some arithmetic and some algebra. 1 minus 5 is -4. But the absolute value of -4 is +4, so that term turns into 4k plus 2. Now let's subtract the 2 from both sides, so 6 is equal to 4k, and divide both sides by 4. And that will give us a k value of 6/4, which reduces to 3/2. I believe that one is a mistake in the answer key. All right, let's take a look at y equals -3 times x plus 1 plus k. In this one, we know that -5, 7 is a solution, so that means when y is replaced with 7, we can replace the x with -5. And doing some arithmetic, that gives us -4 inside the absolute value. The absolute value of -4 is +4. So 7 is equal to -12 plus k, and adding 12 to both sides, k must be 19. For the last one, 3 is our y value, and 5 is the x value. So 3 is equal to k times 3 squared plus 1. 3 squared is 9, so now we have 9k plus 1. Subtract 1 from both sides. Divide by 9, and k is equal to 2/9. That wraps it up.